we've implemented CHERI on our A730 application processor.
Yep.
This is get this right, this is a dual issue in order 8-stage core, which is implemented using our EDA tool, Codasip Studio.
Okay.
And we built it with CHERI right from the start.
Hey, it's Eamon with ipXchange at Embedded World 2024. I'm here with Andy from Codasip. So it's nice to catch up with these guys because they have just won Safety and Security Award in the Embedded Awards. So yes, please explain what happened.
Well, yeah, we're very happy to have received this award at the show this year. So we've won it with our CHERI memory protection technology. This is some brilliant technology. It's been in research with Cambridge University for 14 years now.
Wow.
So we're the first ones to bring it to commercialization. You know, people have done test chips and things like that, but never in a sort of a highly qualified, highly verified core. So I'll explain to you a bit what CHERI is, and then we'll dive into what our implementation of it is.
Cool, yeah.
So CHERI is all about spatial memory safety.
Okay.
So if you think about in a software program, you have pointers. We're going to replace those with what we call capabilities. And so a capability has an address, bounds, and permissions. So instead of a traditional pointer where you can create you can manipulate it and create an offset to go beyond the region that the programmer intended it to be used. We now have bounds that mean that it can only stay within that region and can't be manipulated outside of that without the hardware detecting it.
Okay, cool.
And also permissions as well, so you can limit it to read, write, execute, that sort of thing. Another important thing about capabilities is that they're monotonic. So this means that to create a capability, you have another capability to start with, and you can only decrease the bounds or decrease the permissions. Okay, so if you think about that, it means that a piece of software can't go outside of that space.
Okay.
So you've got fine-grained protection, and you can make sure that it can't create new things to go beyond it.
Oh, cool. So in terms of applications, where do you think this is going to be really important?
So this is important for safe and secure systems. Okay. So it protects against buffer overflows, that sort of thing. And you know, memory safety vulnerabilities are about 70% of all vulnerabilities found in the field. Okay. And if you think about an attack, an attack is a chain of vulnerabilities put together. You know, it's never simple. You know, it's always going to be a set of things. And if we can break that chain by closing off those memory vulnerabilities, the
boundary, I guess.
Yes, exactly.
Cool.
Then that means that chain's not likely to happen, and therefore you're going to stop a vast number of attack chains, and therefore, you know, the devices are more secure.
Cool. Nicely done. So what's happening on this digital board? Is this an implementation? Yeah,
that's right. So we've implemented CHERI on our A730 application processor. This is get this right, this is a dual issue in order 8-stage core, which is implemented using our EDA tool, Codasip Studio. And we built it with CHERI right from the start. So we've been able to make all of the optimizations, all of the trade-offs that we have to make sure that it's the most efficient implementation of the technology.
Cool. So with because you mentioned this has been like 14 years in the making. When did you get a hold of CHERI and then have the opportunity to build the architecture on top of it?
So it's been about 2 years of work for Codasip, looking at it, you know, working out whether it was the right technology for us to utilize. Also working closely with Cambridge University because they had done brilliant research and everything, but you know, we needed to industrialize it. We needed to ensure that it was a specification that fitted in with RISC-V as well. Because they had done a lot of work on MIPS, on ARM, that sort of thing. Really, it was a lot. We've done a lot of work porting it to RISC-V.
Cool. And I guess if people want to test the technology, do they use the digital board for that, or how does it work in terms of is it kind of something at the base layer when you're within Codasip Studio, or is it? Yeah, how does it appear to the engineers who are using it?
Yeah, so within Codasip Studio we have our instruction accurate and cycle accurate simulators which they can use. They can run and profile their code based on that. We also have a QMU model which we're using for software development as well. So we're utilising all of the standard development tools to make sure it's easy for the embedded software developer.
So it's not going to seem completely unfamiliar. You've put the support in.
Yes, exactly.
Cool.
Yeah,
excellent.
right.
Well, thank you, Andy. That's really cool. Congratulations again on the award, and check out Codasip's CHERI technology.
Hey, where my engineers at?